So I'm going to try getting a regression of an exponential curve. So let's say I get these data here is my initial x values and these are my y values here. So I've got my x's and my y's. First thing I'll do is I'm going to drop them into a spreadsheet to do the calculation. So I'll show you how to do that later. But in effect, if I've got something that looks like an exponential, that means that my y value must be a e to the k x. And then there's probably some value of c that's an asymptote. So here's my asymptote. A is my initial value above the asymptote. So that's negative. So if it's positive, I'll get something that looks like this with an asymptote here at c. That's a plus c. And if I have something that looks like this is a plus c again. But if a is negative, it will be below the c, and the graph will go up towards it. And this is generally my multiplier each time I go up by 1, or not exactly because it's an e to the power, but it makes it, the smaller this number is, the slower it goes down, the bigger the number, the faster it goes down. And c is where my asymptote is. So that's what an exponential graph looks like. But what I can do with this, I can say, I could try and find a particular value here and a particular value there and work out what it looks like, but I want to do a regression on it. So to do a regression, the first thing I want to do is estimate the asymptote. When I know the asymptote, I can rearrange this equation. So subtract c from both sides. I get y subtract c equals ae to the kx. And then I take a log of both sides because it's e to the power. Get log of y subtract c equals log of ae to the kx. And now I'll get log of y subtract c equals, here I've got two things multiplied, so I can split them up into addition of two logs, log of a plus log of e to the power kx. But actually, e to the log of an e cancels out, so it's just plus kx. And if we rewrite this like this, kx plus log of a, what kind of thing does this look like? This is my, if these were more y values, I'd have it's like y equals mx plus some value there that's c, because this is just a number. So this looks like a straight line. So what I need to do is try and work out what log of y subtract c is here. So take these values and do a column that's log of y subtract c. And then when I get all those values there, that should give me a straight line. I'm going to do the x's against those values. If I've got a straight line, it won't be exactly, so it might be a little bit wobbling around a straight line. I'll get a straight line. If I can work out my y-intercept, that should be log of a. And my gradient here is k. And so I know those values. I can do, if I know log of a equals k, then a equals e to the power k. So if I've recorded and the y values here, and let's see what kind of shape those make. So I'll take my copy of my data, I'll do insert and get a nice little graph up here. And it's produced a nice little graph for me here. Now it looks like it's going down quite fast and it's leveling out. That implies there's some kind of exponential there. So I need to make an estimate of what the asymptote is going to be. So hopefully it's heading down towards the asymptote. It's going down to 12.8, 12.3. Maybe let's say the asymptote's 10. Might be a bit higher than that, but let's try asymptote 10. So I'll put an asymptote here. Asymptote. And I'll put 10 in there. So that's my value from asymptote. And then I need my equation. So I need to plot the y values, or the values of the y subtract the asymptote. So let's do y subtract asymptote in this column. So I do equals to get that in first, click on that value and subtract the asymptote. and then lock the asymptote. So I'm going to put a $ in front of that to lock the asymptote and then fill it in. Yes, that's correct. So this is now should be hopefully a straight line. Let's look at it and see. So we'll plot this one. Let's put X values. I'll include the title there. Oh, no, so I want the log of that, don't I? So let's add an extra column in. Insert a column to the right. Do log y subtract asymptote. I'll make it ln log, not just log, so ln. And I'll do equals log of this value here. Put it all the way down. And let's see if we get a straight line from that. I'll take these values and control to fill in this dot, sorry, control paint. So command paint gives me these ones, and do insert and then graph. What do I get? Oh, yeah. Now I've got something. It looks a bit more like a straight line. I'll slide it out of the way if I can, so you can see what's happening. So now for these graphs here, I can try and get what the gradient is, which in Excel is slope, so equals slope of the y values first. It's normally a comma, but because I'm in French, it's a semicolon, and the x values here, close brackets. And it's given me, that's the gradient, which is negative, which looks right, it's negative gradient. And then actually I can cheat here, I can take all these ones, it's changed to French because of, if I can type it in English, it changes to French. I'll copy that, Command C, and I'll do equals the same thing, but for intercept, should give me the y-intercept of all those things. That's the y-intercept, 4 point something, that looks right. And let's do Pearson's product moment correlation coefficient equals Pearson of the same thing, the same values. Oh, so that's 0.997, negative 0.997. So it's a very good correlation and it's negative. So that works for me. I've got a good correlation there. And I could even go back to this graph, double click it, double click the series, say, let's have, it doesn't call it a regression line, calls it a trend line, I think they call it, and linear. Let's make it in red so we can see that. So let's put the trend line in there and you can see on the graph, the trend line, it looks pretty good. So we've got a good trend line. So now let's try and find a, now we need to go back and find the correct values for that. So insert a column to the right. And what would my equation be? So normally I want, this is log of the A value. So this is log of A. This is my K value. And this is Pearson's product moment correlation coefficient, so I know what they are. Let's find out what A is then. So it should equal the e to the power, which is exp in this language, exp of this does e to the power. And I've got the A value now. So now I can plot my graph, which should be, this should be regression. Regression, and this should be exponential. So now I can do equals. I want to have A, so it's this, times, which is asterisk, the e to the power of k times x, this times x, the x value is here, close my exponential, and plus my asymptote. I need to lock some of these in place, so that one can't move. Doesn't matter, the letters aren't locked, but I need the numbers to be locked. A2, that needs to move with the values. This one has to stay in place, and this one has to stay in place. And it's filled all those down for me. I'll say yes, but actually it's putting too many. I don't want these ones because they don't mean anything. So now let's see what our regression line looks like. I'm going to plot this one with the y values that we had originally, along with the regression line, the regression curve that we've got now. Insert graph. Oh, and it's added in. I don't want this as an x value. That can be deleted out. And the x-axis needs to be my x values. So there we go. Now we go. Oh, we can see this actually looks like a pretty good curve. Just fit it really well. And the cool bit is because I typed the asymptote in there, I could work out what happens if I've got an asymptote of 12 or an asymptote of 6. Actually, the asymptote of 10 looked quite good, actually, didn't it? There looks like quite a nice curve. So I've got, depending on my asymptote, I'll set different values out, but I've effectively got my regression line. I can show on the graphs what I did with my different graphs as we go along. This is my, I don't know why that's ended up so big now. That should, I can adjust my axes. So this goes from, let's go from, so vertical axis, let's go from 0 to 10, or even 5 we could do. And then that shows me, I could show what my regression line looks like on that and what my values look like. I can see my original curve here. So I go original curve, straighten graph and straighten graph with regression line. And then this is my actual exponential regression. I need to change the titles and put the axes labels on, but I can use those in my actual IA. Log of A equals, yeah. So in other words, if I've not log of A equals, I shouldn't use K because we already used that. Log of A equals P, for example, and this is e to the power P. In other words, if I want to find A, I just take my log of A, which is my y-intercept, and do e to the power of it, and I'll get my actual A value here. So I can then fill these values into the equation. All I have to do is estimate my value for the asymptote. So let's see what happens with that on a spreadsheet and see if I get something that looks reasonable. And so we've ended up with y equals e to the power, sorry, it's A first, isn't it? Equals 84.6 e to the power negative 0.189 x plus 10. And that's my equation. It gives me a very good graph and can use it in my IA.